Hey yo, what's up, YouTube? It's your boy JOSHABRAHAM in it, and we are back with day 5 of coding journey. It's the day 5 of the coding. I wouldn't say coding, but it's still it's somewhat coding. And the last thing I made was the density graph. Flash pressure plot. What the? What? It should be here. It should be here. Okay, I'm back using the GROMACS. I have to continue where I left off. Oh, come on, just, yeah. Yup. NTP equilibration is complete. Existing in download for pressure plot was saved as pressure plot. Your previously done terminal was closed, so any running simulation was stopped, but your completed NPT but saved. Next step: organize files into a dedicated folder for safety and clarity. Nah, not right now. Okay, I did this one. Come. These were the last codes on terminal before closing, and I did save the pressure. So what's next? Can I just paste the for the density? I'm talking this one. Let's take a look at density as well. I'm talking about clone open commander. Do you think I'm about to finish? Do you think it's almost over? Because I got till the density part. Oh, I forgot. Oh, yeah. Exactly, that's the correct command to extract density on your completed NTP run. Let's just... Invalid command, that's what I got. Copy. Paste this. No, I don't think. Let's just go the full path. Oh, okay. Density. Density is what's the number for density? There's no density. Tough. 23 0. 23. It's volume. That's the volume. What do you have to say? Over the course of equilibration, the average value of pressure is the reference pressure. So, with the pressure, 24, right column. How did you notice that? Okay, that's there. So if I remember, it's 24 0. Last energy read, copy, paste. Density is 1019.28. You can now create a plot of density in the Python just like you did for pressure. Let's use the spotlight. Density the plot the also what should I name the file? I'll be back. Yeah, of course. I really appreciate being here. Plot density.py, simple and clear. Okay, that's what I want. And we take EDC and we paste EDC. There is one issue. Unused import statement. On which line is this? That's the third. Okay. So at the third line, I did see a problem pointed out by PyCharm. That's just a linting warning by PyCharm. I tell you what is doesn't affect the execution. Okay, it's not that important. Okay. Let's run the current file. Plot saved as densityplot.png in the downloads folder. Usually Python shows me the plotting. Shows the plotting. So you set a timer for 1 hour. Okay. Got him. Got him. What? What you turn off, bro? What you turn off yourself, bro? What you turn this shit on? Uh, 1020. Pretty good. Pretty good. As the pressure, the running average of density is also plotted in red. The average value of the course of 5000 p is higher than experimental value and expected density of 2. I'm not getting every terminologies. Is this result reasonable? We have not simulated pure water. Instead, there's a protein in our system and some diffuse ions. Therefore, we should not expect an exact math. And during equilibration, we need only to see the density as stabilized. Upon completion of 2 equilibrium phases, the system is now well equilibrated at the desired temperature and pressure. We are now ready to release the position restraints and run the production molecular dynamics for data collection. The process is just like we have seen before. We will make use of the checkpoint file, which is in this case now contains pressure coupling information to GOMP. We will round 10 nanosecond mole MD simulation, the script, which can be found here. Is the MDP Run parameters. Velocity generation is off. Okay. I forgot. Control O. Okay. Yo, back. Hell yeah. Well, I believe I'm somewhere. Production MTP is running successfully. GROMACS reminds you, hey man, I'm really okay. I felt that. I felt that. Simulation has started. You don't need to interact with the terminal while it's running to monitor progress, maybe. Let me monitor the progress. Okay, there's no fetch file. We're in downloads. The TP file exists. I think it exists because okay, something's happening. It's running. Okay. So we are running a mini simulation for 100 picosecond. You are running 500,000 steps corresponding to 1000 PS. Okay, I thought it was 100 PS. 1 nanosecond with current time step. Damn it. All my 8 MPI threads are running using. Check out the output file during or after the run. You should see. Oh, okay. Let me see if they. There is ADR, XTC, JLOG, TPR, EDR, TRR. What? What's the XTC? Mm-hmm. It's kind of weird. Check in a separate terminal if you have a .log file. This is how you check, right? Whoa, what? No matches found. What? Why? Well, I used this command to check on another new window terminal. I got no matches found. Oh, you need to, okay. Okay, let me try this. That should include the downloads folder. It did not. Well, let's then first go into downloads. What is, yeah, CD downloads. And then we, I believe this, no. I believe this one. It is there. It is alive, it's alive. That confirms your production MT is actively running and writing outputs. Here's what each file is. Your input file for MT run, the log file which has been written as simulation progresses, energy file containing temperature, pressure, density, potential, and energy, compressed trajectory storing positions of all atoms over time. I'm really interested in the last one. Next step, monitor progress using log file. I mean, can I though? Can if I run this here, do you think I could get it? Oh, I could. Okay. Bond 5 3. At step 6000. Turning off dynamic load balancing because it is degrading performance. Atom distribution over 8 domain. AV42. Something big is happening. It's going to print this information over and over. So is it, should I stop? Should I press stop or something? Control C. Oh shit, okay. Think I saved myself up there. So, but usually, so now we just wait. But you know, usually I see a sort of like the simulation or the process would be ending in 1650, or you know, give me some sort of time, but here it's not given anything. That's weird. We have plot pressure.py, pi. Probably you didn't requested it to do it in the input. Oh, okay, so you have to request. I gotta ask this ChatGPT, yo, why don't I see the time usually you need GMX MD run name. The V will give you the information on the run. Ah, this one. See, the ChatGPT agrees. Okay, now we got a verbose flag. Run the V flag. I don't know if I could run it here. Can I though? So CTRL plus C, the current run. I have to close it? And performance. Average load imbalance. Now run with the V flag. Okay, maybe. So I is this? Oh, okay. 19. 19? Wow. That's about 2 hours. No, it's about 3 hours. It's gonna take that long? I see the limitations of computers. Yeah, if you want 100 PS. I can see the limitations of my computer right in front of me. On supercomputer, it runs for days. So, okay, now let me just paste this. Now I got this. Oh no, ChatGPT is thinking longer. What happened? And now execute in GROMACS 2025. PME calculations can be offloaded to graphical processing units, which speeds up the simulation substantially. Using a Titan XP GPU, this system can be simulated at an astounding 196 nanosecond a day. A day! A day! Running GROMACS on GPU as version support GPU acceleration running. With releases of version 2018, non-bonded interactions and PME are calculated on GPU with only bonded forces calculated on CPU cores. When building GROMAC For installation instructions, GPU hardwares will automatically be detected if percent. Too bad your Mac doesn't have a GPU. Yeah, I'm glad it has a CPU cores. Require customize. Okay, so if you have a GPU, I'm thinking. Let me get my money up. Let me get the money up. I will get the GPU. A lot of stuff to do with the GPU. Oh no, it's getting late. I think this is the for normal the simulations. I don't know if the last two times what I did was simulations, but the last two times I'd get these timing, it was like 40 minutes, 30 minutes it would be done. You could simulate it for like 1 picosecond instant and then just look at the next steps. Ah. So if I wanna do it, how do I? If I wanna do one step at a time. Useful commands you could run. Uh-huh. What if analysis? More analysis. Okay. Correcting for periodicity effects. Uh, with parameters inside 1000. Okay, it's 1000. If you want to simulate 1 PS, you need to change the number of steps. Uh, Looking at the next steps afterwards. Once you finish that 1 PS run, you'll have a checkpoint. You can restart from that checkpoint to continue another PS or however much you want. Why don't you usually do 1 PS at a time? Molecular dynamics is noisy on sub PS timescales. Equilibration and meaningful motion happens over tens of PS. If you stop at 1 PS, you'll mostly see initial jitters. But if your goal is to see how the system evolves step by step, doing 1 PS runs and continuing them is totally fine. It's like stepping through the movie one frame at a time. Okay. do you think? Gen velocity, no. Make a new folder for the short test. GPT, just come on, bro. Okay. Copy the needed files. Please don't mess it up, GPT. Create one with this. Here is where you change. How is the terminal doing? It's gonna go past tonight, 10 p.m. Nah, save it directly. I don't know if I made the. Mm-hmm. After that, you are ready to run. Uh-huh. I didn't give it the time stuff. I think it's very important to get more women into computing. My slogan is computing is too important to be left to men. Not gonna lie, I agree to that. But my problem is this gonna slow down the other one, or the other one is gonna slow down this? I I believe it's gonna slow down, but how slow are we talking? Can I get this fast? They will slow each other down. Oh, so I can't. So I mean, I really want to see this, and I want to see this. Normally, GROMAC prints updates every 100 step, but because the whole job is just 500 total, the run is over in seconds and often finishes before GROMAC even prints ETA. Well, I'm not seeing anything. Again, a new terminal window. Really? Nope. Oh, I have to do the C downloads. Where's the CD downloads? Oh, it's done. Done, done, done. Let me just confirm. Copy. Hell to the year. So that's done. I believe. Dynamic load balancing report. DLB was off during the run due to low measured imbalance. Average load imbalance 11%. The balanceable part of the MD is 15%. Load balance is computed from this part of the run. Performance. Okay. Writing final coordinates. Mm-hmm. Inspect energies. You can extract any energy time series from EDR produced by this run. Example, the prompt will ask which term to select. Ah. My computer is slow. It is. I can feel that lag. So this. Oh, it's still going. Now that we have simulated a protein, we should be run some analysis on the system. What type of data are important? This is an important question to ask before running the simulation, so you should have some ideas about types of data you want to collect on your system. For this tutorial, a few basic tools are introduced. First is StretchCove, which is used as a processing tool to strip out coordinates, correct for periodicity, or manually alter the trajectory. For this exercise, we will use StretchCove to account for periodicity. For a system, the protein will diffuse through a unit cell and may appear broken or may jump across. Mm-hmm. Oh, just what? You can't even. Oh, my eyes. Okay. What happens to the prompts? Select a group. What does this say? One protein. Damn, GPT was just going. Oh, system, okay. What? What? GPT is tweaking. VDM. I heard of this name. What's GROMACS viewer? Let me see what the hell is GROMACS viewer. Is it available? No. There's no app called GROMACS viewer. Check the frame. If dumb1000 looks wrong, use dumb1 or simply. You can choose common analysis commands for brief notes. Backbone or whole protein. Per residue fluctuations. Radius of gyration. Hydrogen bonds. Okay. Distance between two atom groups. Example. What's this guy doing? What's the other guy doing? Not this guy. There is one more guy. It's one more terminal back here. My first simulation is gonna end tomorrow, September 9th. I'll wait till ChatGPT stops yapping. I'm pushing my computer to the maximum. To the max. GPT, you're still going? How long? How many hours has it been? I think it's about 1 hour, maybe. Cause I gotta eat something. I'm pretty hungry. 58 minutes. Okay. Oh. You are still going on GPT. What the fuck is wrong with you, bro? Hmm. Well, looks like I have to end my YouTube stream because it's about 1 hour, and I would continue this part after my food session. So this you could see the continuation today itself, at least if it completes today. Where's the other one? Where's the big boy? Yeah, this guy. It's saying that it will be complete after 12, so I don't know how it's, but I'm gonna let this run. It's gonna be running. And after eating, I will be doing my thermodynamics. I have extra questions. I'll look into those. And I have chemical calculation homework. What else? I have to redo my section 6 lab protocol. I have to write those. So those are the stuff. And YouTube, peace out, YouTube. I really appreciate this.